To create this adaptability, the designers of this super sub create what's called a modular design that incorporates an open system architecture, meaning the skeletal structure of the sub includes large open spaces. These open spaces can house prefabricated modules such as weapon systems or sonar technologies. These modules can easily be inserted as one complete unit. This modularity will allow future versions of the Virginia class to house newly developed systems in the existing Virginia class layout, without the added expense of having to develop an entirely new class of submarine to house new technologies and capabilities. A remarkable cost-cutting development in the design of a submarine. If it works, this will be the most extraordinary submarine commanding the world's oceans. But designing it is just one problem. Making this ambition a reality is quite another. With an even tighter budget than past submarines, this is going to be a massive challenge to execute. And now there's a new problem. Having spent millions on the design, the Navy may not have enough money left to build it. It looks like the prototype of the new Virginia class may never surface. The Navy is underwriting an enormous new project to build a new class of submarine that'll be more versatile than any ever built. But it has to be constructed in less time and for less money than the previous attack submarine, the Seawolf. The design and development have been skillfully and successfully carried out by Electric Boat. And for the first time, a US Navy submarine is completely designed via computer. It's a massive achievement, but there's a problem. The Navy's budget for the Virginia program is running out. It could lead to the end of the new super sub before it's even floated. But then Electric Boat does something unprecedented in its history. For years, Electric Boat has been in competition with Northrop Grumman's Newport News, another heavy hitter in the shipbuilding industry. Now Electric Boat proposes that they combine forces with their old rivals and do something that's never been done before. Build the submarine together, a process they call teaming. They figure that combining resources and brainpower will allow them to work more quickly and more efficiently. The proposed alliance can lead to massive savings, $700 million off the cost. But can these two historic adversaries put aside their differences and build a super sub for a reduced price? How can they manage such a massive project across two companies? As we've said, it's never been done before. But the allied companies must make it work. They have little choice as the Navy has no more money to offer. Making a super sub for less money and in less time than previous attack subs will only be possible if the two rivals collaborate. It's a colossal and dangerous undertaking. If they get it wrong, it could spell the end of the US submarine program. This is a time when the Navy must prove a submarine's worth in a changing world. The two-company alliance agrees that the only way to meet such demands is that there can be no delays. A major setback could erase any cost savings. But such efficiency in submarine construction is unprecedented. Is this project simply too ambitious? Could it be destined for the deep? In 1998, construction finally begins. Like all submarine building, it begins with the most crucial component, the hull. This is where the crew and weapons are housed. If it's not strong enough, the lives of hundreds of men are at stake, as is the multi-billion-dollar submarine. Not just a costly mistake, it would be a national catastrophe. Consequently, the hull for this sub isn't just made out of simple steel. It must resist unbelievable pressure. The Virginia class needs to reach depths up to 240 meters. Here, it's difficult for an enemy to find them. It'll give the submarine maximum safety from attack or detection. But at these depths, there's immense pressure. The steel hull must withstand a massive 26 kilograms of force per square centimeter. That's the equivalent of a dinner plate strong enough to hold up to the weight of an elephant. Getting the steel strong enough to endure such pressure is crucial. The manufacturing of this special metal is a military secret, but suffice to say, it's strong. Extremely strong. But now the problem is how to bend such heavy-duty steel. They use a machine that supplies up to 4,500 tons of pressure. That's over 30 times the pressure exerted by this car-crushing machine. The massive drum shapes and bends the huge plates of steel. Once bent into shape, the steel is mounted onto rib-like frames. It's then welded together into cylinders. This is a critical moment. In the past, this was done by teams of hand welders. But such are the stresses on a deep ocean submarine that even one bad weld could lead to disaster. There's only one answer: robots. These assembly robots can work round the clock and rarely make mistakes.
The weldments that go in out here are better than 99% first-time yield, which means the inspection process is less than 1% failure rate.
It's a costly business, but this is something that can't afford to fail at any price. To make sure the welds are perfect, they're inspected by X-ray. Any imperfection, such as an air bubble in the weld seam, could be just enough for the hull to weaken. It could then give way to the crushing forces exerted deep below the surface. If the X-ray machine shows up any imperfection, it's meticulously repaired. Amazingly, once the seam is perfect, the welds can create a bond that is actually stronger than the original steel. A comforting fact when you're 240 meters below sea level. Once the separate sections of the hull have been created, they start to construct the skeleton. Here in steel processing, they'll make floors, walls, and all the sections that comprise the submarine's framework. Again, robotic manufacturing reduces mistakes and speeds up the process. This is crucial when the alliance companies are desperate to cut costs and time.
Today, modern technology, we're working with electronic data, comes right over the line, feeds the machines. It's incredible.
This incredible laser marker is one of a new generation of robotic assembly. This tool is designed to eliminate human error. It's programmed to follow the computer design with better than pinpoint accuracy.
Basically, it's the only marker of its kind in the free world that we're aware of.
But will this new technology work? It's never been used in submarine construction. The machine passes quality control with flying colors. It's just one of many innovations in building this unique sub. So far, the project is going well. Now the marked steel must be cut. But how do you cut such strong steel? They use a hugely powerful cutting machine known as an abrasive water jet. Here, a constant stream of water acts as the propellant for 80 grit flecks of garnet, which cut through the steel. The advantage to this method of cutting with a cold water propellant is that there is no heat-affected zone, thereby eliminating imperfections caused by expansion, contraction, and melting. Even though garnet is not the hardest abrasive that could be used, it's seen as optimal because it's hard enough to cut without causing too much wear and tear on the water jet's nozzle. The powerful cutting stream strikes the steel with 3,900 kilograms of force per square centimeter. That's strong enough to cut through a 30-centimeter thick piece of steel. Once cut, the sections are ready to be welded into place. This makes up the submarine's skeletal shape. While these sections are being built, other important modular sections are constructed in tandem. Living quarters and weapons are built outside the submarine before final assembly. This allows ease of construction. It can then be rigorously tested before installation. The Virginia's command and control module is the most complex module to be built. It's the brain of the sub. It's where crucial functions are executed and surroundings monitored. It's also where the awesome weapons systems are controlled. If any part of this goes wrong, the whole submarine could be rendered inoperative and end in a voyage to the bottom of the sea. So the Virginia's separate elements, the modular systems, the internal structures, and the outer hull are built with efficiency. But these separate sections have not yet been integrated into a complete submarine. And without a complete submarine, the sailors destined to serve on the Virginia can't set foot onto it and get a feel for its inner workings. Yet they must have a working knowledge of the Virginia's unique operating systems when they're charged with manning the complete submarine. So how do sailors prepare for duty on board this unfinished sub? The Navy would have to get creative to ensure that the human element of this mega-sub, the US Navy Submariner, would also be finely tuned for service. This is when the mission could sink or swim. The USS Virginia is a super sub in the making. Nothing like it has ever been built before. So there's no chance of gaining crew experience from other submarines. But the new sub must be fully tested before sea trials. That includes the crew. To operate this new class of submarine will require unique training. But this is a virgin sub, and no one knows all its workings. Like the rest of this project, this too will be a challenge for the Navy to resolve. Training begins with every submariner's nightmare. In mock facilities like this fake engine room, built to simulate a flood. And even though these men are not on an actual sinking sub, this scenario is very real to them. They know that a flood could happen when they're at sea, and the only way to survive it is to stop the water from rushing in.
Flooded in the engine room!
When a sub starts flooding, it becomes a race against possible death for everyone on board.
Flood control has been activated in the engine room. Phones are manned and damage control central.
In the heat of battle, the sub can't resurface because the enemy will spot it.
Overlow level DC central line. Understand you have major rupture MSW discharge.
If too much water gets in, the sub takes on too much weight, permanently ditching itself on the ocean floor. The men cannot escape through the hatch because they're so deep. The water pressure will crush them. If they can't stop the leaks, they will be trapped at the bottom of the ocean, buried alive in an iron coffin.
Hammer.
These sailors are under the close scrutiny of their commanders.
49. Slow down.
To block small leaks in pipes, the sailors hold plugs in place with rope they call bandit twine. For larger leaks, the sailors patch the holes with rounded metal plates called strongbacks, which are secured with metal straps simply called bandits.
Don't take it apart. Don't take it apart. Tie it up.
Commanders expect the sailors to keep their cool and keep their